Hi everyone, welcome to Virginia Tech Giving Day. I'm your College of Engineering host, Marie Gottman. I'm a senior here in aerospace engineering, and thanks to donors like you on Giving Day, I have been able to intern abroad, I've received a scholarship, and I've been able to get involved in really cool research and design teams like the ones we're looking into today. So we're going to kick off today with the Participation Leadership Challenge. We're competing with all other groups across campus for the most donors. Last year, the College of Liberal Arts and Science and Human Sciences barely edged us out in participation, so we don't want to let that happen again. Every person counts, every dollar counts, so please donate. So to get started, we're standing outside of the lab of Hyperloop at Virginia Tech. This team will be going to SpaceX in California this summer to compete against 20 other teams from all over the world. They design a pod that can transport people super fast through tubes, and it can revolutionize transport. So much so that we could possibly travel from Washington, D.C. to New York City in only 30 minutes. But that's enough from me. Let's hear from the team members themselves. So let's go in and talk to Chief Engineer Bobby Smythe to learn more about what they're doing. Hey Bobby, thanks for having us in your lab.
Hey Marika, welcome to the Design Center.
So what is Hyperloop?
So Hyperloop is sort of like the brainchild of Elon Musk. Basically the way it works when he first described it, it's a mix between an air hockey table and a railgun. You also might liken it to the tubes that deliver your supplies at a bank teller. So the way it would work is you'd have a passenger vehicle that you'd have maybe 10 to 20 people inside of, and it would travel inside of a tube that has all the air depressurized and also levitate. Through those two means of technology, we can actually achieve very low drag, which allows us to A, go at high speeds, B, eliminate sonic booms, and C, be very environmentally friendly because we have very little losses of energy in the system.
So you're saying that these things go fast, but just how fast are we talking?
So we're talking starting out probably 400 to 500 miles an hour, which is, around what you'll see on a commercial airliner. And then in the future, as the technology matures, we might see higher, 600, 700, 800 miles an hour.
Oh, that's incredible. I'd love to see that. And so you said this is Elon Musk's drawing.
Yes.
What are you guys doing here at Hyperloop at Virginia Tech?
So Hyperloop at Virginia Tech develops concepts for the technology that will go into these systems. So we think of it at a high level and also at a low detailed level. So you'll see over here a concept, a rendering that we've created of the actual Hyperloop transportation system based on pods that we've developed here at Virginia Tech. Now, the actual vehicles that we are building and designing as part of this competition are 1/8 scale models of these systems without the cabin, but primarily focusing on the technology that's used to propel the pod. So we're developing different techniques to operate correctly inside of a vacuum, achieve levitation, and that sort of thing.
Wow. Do you have anything closer up? I'd love to see the seats.
Sure. So the experience would be something like a business or first class airline flight. One of the major benefits with this, however, is you wouldn't have to show up to the airport an hour before, 2 hours before. You could show up 15 minutes before and catch the one that goes 10 minutes later. These are designed to operate much more like subways or buses, so a lot of the convenience is improved relative to airliners.
Oh my gosh, so this is an incredible rendering. Do you have any parts built yet that we could look at?
Absolutely. So we've been working on the manufacturing phase for several months now. So I'll pass you over to one of our other team members, Teja, who will tell you a little bit more about that.
Oh, great. So Teja, what are we looking at here? What is this giant piece?
So here we're looking at the mold, which is what will become the aeroshell for our pod, which is a structure that's going to cover all of the subsystems and make sure they're protected when it's traveling in a vacuum. So here, this mold is called a plug, and what it consists of is foam followed by a layer of fiberglass with Bondo on top, and then from this we're going to make a fiberglass mold, and then that's going to be the first step to make our carbon fiber layup for the aeroshell.
Wow, and what does the carbon fiber layup entail? You're putting it on the outside of this mold?
Yeah, so after we get the fiberglass mold off of this plug, we're going to be laying pieces of fabric of carbon fiber on it, followed by vacuum bagging in alternate amounts, and then we will ultimately be taking it to an autoclave, which is a giant oven where we'll be baking this whole thing for about 4 hours.
Wow, so you're wrapping it, vacuuming it, and baking it, and then we'll get a
Exactly.
nice Hyperloop pod. That's incredible. So what goes on the inside of this part?
Sure, I can show you a blueprint of what we're working on.
Yeah, absolutely.
So this is a schematic of our pod. In the front, you'll see our stability systems. Those consist of the vertical and lateral suspension modules. Over here is our battery pressure vessel. This is really key because it's going to be holding all our batteries and making sure that it won't explode when traveling in a near vacuum. Over here we have our braking system, and it's actually a system of redundant braking because safety is key. Over here we have our drive system, so that consists of a quad motor driven drive wheel. We have 2 drive wheels. Over here is our pneumatic lines, and that's going to be powering our brakes as well as our drive system. Over here is our control box, and then in the end we have another stability module, and the whole thing is encased by the aeroshell, which is what you saw earlier.
So just for some perspective, this looks like a lot of work. How much time did it take all of you to design this?
So since the start of this competition cycle, we spent about 6 months designing all of the subsystems that you see, as well as working on the manufacturing, which we're doing right now.
Oh my goodness. And could we take a closer look at some of these subsystems?
Sure, so my other teammate Nick will walk you through a little bit.
All right, Nick, so which subsystem are we looking at here?
So here we have some hardware for the stability systems. These are the systems that Tasia mentioned go on the front and back of the pod, and they work sort of like the suspension in a car to make sure that the ride of the pod is stable. So you can see how they interface with the I-beam, which is the track that the pod runs on. There is wheels on the top and bottom of the flange, as well as lateral wheels, which allow it to maintain its lateral alignment. This is a piece of hardware for the lateral stability module. This will contact with the web of the I-beam here. This is actually mounted on a fixture that we'll be using for testing. Both of these parts are the mounting components for the suspension modules, where you can see these parts here.
So I've never really seen anything like this. Is this custom designed and custom built by you?
Yeah, so all the parts that we make are pretty much custom made besides bearings and bolts and stuff.
Oh my gosh. And you said that's much like the suspension system in my car. Now what I'm looking at on this second subsystem does not look familiar to me at all. What is this?
Yeah. So this is our battery pressure vessel, and as Tasia mentioned, it's used to hold our batteries. Because we're operating in a vacuum environment, we need to hold the batteries at pressure, so it needs to create a seal so that air doesn't leak out. This is because if the batteries were exposed to a vacuum, there would be some issues with the performance of them. So for this, basically, as you can see, that's how the batteries wouldn't fit inside. And then there's pass-throughs for the power as well as electrical connections to the batteries. We're working on 2 designs for this because it's such a critical subsystem. One of them is the carbon fiber piece here, which you can see the hardware for here, which is this aluminum plates, and there would be a ring of carbon fiber. And then the other is a welded design, which would allow for a really great seal and be strong, but we won't be able to tell until both of them are built to make sure that they're able to hold the pressure for the extended period we need them to.
And then what is this here?
So this is our propulsion system, which is the main part of the pod that we're working on. So it allows us to move at the speeds that we're during competition. This consists of 4 motors and then 2 drive wheels. We're able to accelerate at up to 0.5 Gs with this system, and the motors total produce about 50 horsepower. So for a pod that only weighs 120 pounds, we're able to reach speeds of 175 miles an hour.
Oh my gosh. And again, this looks custom designed and custom built. You guys are a competition team.
Yeah.
Did we just give away all of your trade secrets to the competitors? Or?
Well, I mean, as part of the development of the technology, we need to be able to open and explore new opportunities, but also as we're nearing the end of the competition, there isn't much time for someone to copy what we've done.
Yeah, so maybe perhaps next year, maybe this team or one of the competitors may have something similar that's built upon it or
Mhm.
improved it, you know.
Yeah.
So even though it is a competition, it is
Yeah.
still a very collaborative environment.
Yeah, still
Well,
making progress forward.
Yeah, well, that's excellent. So please put any questions you have in the comments below. We're going to do a Q&A session at the end. But just before we do that, we're going to learn a little bit more about what it means to be on this team and hear from some of the team members themselves. So guys, I've been dying to ask all of you. I mean, this is a lot of work, and this is outside of your daily class schedule. So why did each of you get involved in the first place, and what's the favorite thing that you get out of it? We'll start with you, Nick.
Okay. So I joined 3 years ago, mostly because I was looking for some hands-on experience and actually, making practical stuff. And I've continued to love it just because at the end of the day, I get to see a final product and I get to, have some creative output and create custom parts, like you said.
All right, what about you, Tasia?
So for me, I joined my sophomore year, so that's 2 years ago, and we're all actually seniors now. But I joined because I was really excited about a new system of transportation because I've never heard of anything like the Hyperloop before. And also I knew that with something this revolutionary and new, it would bring a lot of different minds to the table, and getting to work with these guys is really rewarding.
And kind of coincidentally, when I was in high school, 5 or 6 years ago, I actually started a design team at my high school that was focused around kind of thinking about how a Hyperloop system would be developed. So this is before I had any really the technical expertise to actually start building the system. So when I found out that there was a team at Virginia Tech that was doing this sort of thing, I was instantly drawn to Virginia Tech. And I'm very, it's been the defining moment of my college experience to be able to work on this project, go out to California, and it's really kind of shaped my entire experience here at Virginia Tech.
Amazing. So one question we have is, what is the history of this team? How did you guys get started? How young is this team? What would you say?
So this team has gone through multiple design iterations. So the competition has started shortly after Elon's white paper back in 2013. So every year we design a new pod from the ground up. So in the past we focused on different aspects of a Hyperloop system. So in the first year we focused on our magnetic levitation system. We were able to go out to competition and achieve levitation. Then in the subsequent competition we worked on a cold gas propulsion thruster. Basically it's the sort of system that satellites use to maneuver while they're on orbit. And then the past 2 years we've been developing electronic propulsion systems like the electric motor we just showed, that will allow the pod to accelerate very quickly and still be very lightweight.
Amazing. And going back to these competitions that you attend every year, how has your performance measured up against the other teams?
So we've been performing really well in previous competitions, starting from the first competition, which was just a design presentation. We placed 4th, and then moving into actual build competitions, we've also were able to place 4th behind teams such as Delft from Netherlands, TU Munich from Germany, and then MIT, which is obviously a powerhouse of engineering. So we've stacked up pretty well against the top competition.
Incredible. And I think we have someone possibly interested in joining or a new fan. They want to know, where is this team located?
Sure, so we actually operate out of this room. We call it the Design Studio for Hyperloop, and it's a room on campus. If you're interested in joining, we have links to join on our website that you can apply on.
Great. And we're on the 6th floor of Whitmore. You can Google them to find out more if you want to come join us. Don't come in right this second, maybe in a few minutes. We've also gotten asked about what your past pod designs were like, especially compared to the one that you have now.
So one of our most successful pod designs was from back in 2017. In that design, we used this cold gas thruster system you see behind us. So this sphere that you see is a pressure vessel made out of titanium that was donated to us by an orbital ATK. Inside of that, we have compressed nitrogen gas at 3,000 psi. It will then go through a series of valves and ultimately exit out of a converging diverging nozzle. That provided us thrust to get additional acceleration or velocity increase relative to the rest of the competition.
Incredible. And last question, but definitely not least, people want to know, how can they give and how can they donate to your team?
So we have a link posted on our Facebook page, but you can go to the Student Affairs page on Giving Day and select to donate, and we are under the account or I guess the account field, you would enter Hyperloop at Virginia Tech.
Okay, great. Yeah, so check out Hyperloop at Virginia Tech on Facebook to stay in the loop. Haha. Until then, please tune in at 4 p.m. today as we go to the Soha lab and check out a flying snake. Thanks, everyone. And thank you guys.
Absolutely.